Item 8 is for discussion and possible action presentation by Ryan Wheeler from Horschgren and Associates regarding the Bunkerville Secondary System Study. Mr. Wheeler, or I guess we're going to have Aaron first.
I'm just waiting out the projector. I should have done that
I don't
second
know
ago.
if you're going to be able to see the screen from over there. Sandra, I don't know.
I can blow it myself.
If you want to trade chairs with me.
Did we get the popcorn?
Oh, I forgot the popcorn.
Yeah, it's
Or you can follow, she's got the presentation in the book there, so if you want to follow along with the book. So,
I'm good.
whatever you guys want to do.
I'm good. I can see.
Students snuck off. There goes Lincoln County.
Hey Rich, will you do us a favor and turn off one of those main lights?
There we go. There you go. Catch some sleep.
Hey, look at that, musical.
Well, members of the board, it's good to be with you. I'm Ryan Wheeler with Horschgren Associates. It's good to see you again. This study has been a long time coming. We've had some staff changes on our end. We've had some staff changes on your end, and so we've been on this project for over a year. The information is very, I know it very well, so I don't want to just grace over it. So if you have questions, just ask throughout the process, throughout the presentation, and I'll answer them the best that I can. Let's see if this works here. There we go. So the Bunkerville Secondary System, a little bit about it. It has 212 users. There's 5 high-volume users and 207 residential users. All of the users are unmetered. There's 3.9 miles of distribution pipes and 1 water tank that holds 500,000 gallons. There's 1 shallow groundwater well. It's a 20-inch casing. It's 80 feet deep. It has a 10 horsepower motor that will pump 160 gallons per minute. And there's 1 booster pump house with 3 pumps in it, 1 10 horsepower pump and 2 30 horsepower pumps. The system uses 260 acre-feet, or 85 million gallons annually. Just real quick, here's a map of the Bunkerville Township. I guess I could use this pointer. Maybe I'll try that. Alright, so as you can see, here's the elementary school, the cemetery. Most of you that are familiar with the area, obviously. The 11-acre site that the district owns is right here. We looked at an option of moving some facilities to there that I'll talk about later. This is the tank, and there's your pump, and that's your booster pump. You may note the number of dead ends. There's a number of dead ends in the system, and so I'll talk about that briefly here also. So, per staff's direction, they had us review 6 alternatives, and I'll just introduce them to you real briefly, and then we'll move forward with the engineer's recommendation. Number 1 is to abandon the system, and this is just to leave it in place, leave the pipes dry. The users would have to connect to the potable water system to irrigate their outdoor needs. Alternative 2 is to not change the system at all. That means the district would just continue to use it how it's being used today. Alternative number 3 is to enhance water delivery through proactive management. And this is just a nice way to say that we recommend that you would add flushing valves to the end of the dead end pipes, which would help flush some of the scaling that has happened in the distribution pipes and the clogging that has occurred to the sprinklers and things like that. Alternative 4 is similar to alternative 3, except you would abandon the residential connections and only use the system for the high volume users, and if you remember, there's only 5 of those. Alternative 5 is to utilize Virgin River water through the district's Bunkerville Irrigation Company shares. So this would change the quality of water that the system uses today, because the water from the ground well is different than the quality of the Virgin River water. So you get a little bit better water quality. In order to do that, we'd have to build some infrastructure to get the Virgin River water to the facilities, and we put in some settling basins to help settle out some of the TSS, or the total suspended solids in the Virgin River. Alternative number 6 is essentially the same as alternative number 5 as far as the mechanics of it, but we would move the facilities to the 11-acre site that the district owns there in Bunkerville. In doing that, we would pump water from the ditch up to that site. We would still have a tank, some settling basins, and then the system would turn into a gravity-fed system. But in order to mimic the pressure that the system uses today, we would probably have to pump that a little bit and pressure that up a little bit more. A little bit of history on the progress of the project is originally our scope included 4 alternatives, and during the process of the project, district staff added alternative 1, which was abandon the system, and alternative 4, which was abandon just the residential connections and maintain the high volume users. So here's the 6 alternatives reviewed. Again, alternative 1 is to abandon the system. You're like, well, why would that cost any money? Well, the money that it would cost would be to switch the connection over to the, since they don't have secondary water, you have to provide potable water to their secondary pipeline infrastructure. So to switch that connection, down here at the bottom, the district would have to determine if that was going to be done in-house or by certified plumbers. We estimated that it would be done by certified plumbers, so that's your initial capital cost. With that, you'd have an annual net savings of $155,800. And I'll describe that fee a little bit later on. Alternative number 2 is to do nothing, to keep it as is. So you'd have $0 on your capital cost, but you would have a loss of $88,000 annually. And I'll discuss that loss here in the next couple slides. Alternative number 3 is to just put in the flushing valves at the dead end points, and that again would have an annual net loss of $88,000. Alternative number 4 was to abandon all the residential connections, keep the high volume users, the 5 high volume users, and there's the cost associated with it. Alternative number 5 and alternative number 6 are your large capital improvements, and there's the associated costs with those. So there's a look at all the costs. Without going through each of the alternatives, each of the 6 alternatives in greater depth, I'm just going to proceed with the engineer's recommendation.